Well, the 8.8 magnitude quake is the sixth strongest on record and the biggest since the 2011 quake that hit Japan. The fifth most powerful also hit Kamchatka, the Russian peninsula where today's quake occurred. A magnitude 9 earthquake, which happened in 1952, caused significant damage but no reported deaths. In 2011, a magnitude 9.1 earthquake struck off the coast of northeastern Japan. More than 18,000 people were killed in the quake and resulting tsunami. The 2004 Boxing Day tsunami also resulted from a 9.1 magnitude quake off the Sumatran coast. It devastated parts of Southeast and South Asia and East Africa, killing at least 230,000 people. In 1964, a 9.2 magnitude earthquake jolted Alaska's Prince William Sound, more than 130 people killed then. And the most powerful earthquake ever recorded happened in 1960 in Chile with a magnitude of 9.5. It resulted in more than 1,600 deaths in the country and further afield. Let's bring in our science and technology editor, Tom Clarke. And Tom, an 8.8 magnitude quake triggering a tsunami that travels as fast as a jet plane. This is nature at its fiercest.
Yeah, absolutely. And this is a very big earthquake, as your little historical run through there just illustrated. It is right up there with some of the largest earthquakes we've seen. And the reason for all the alarm and the concern is that typically these earthquakes generate powerful tsunami waves and can cause widespread damage and destruction and loss of life in populated areas. What is so far seeming to emerge here is that we haven't seen a significant sort of Pacific-wide impact. The waves certainly travelled past Hawaii now, it seems pretty clear, but not significant enough, given the warnings in place as well, as far as we can see at this stage, to have caused much disruption there.
And this is Russia, isn't it?
This is the Kamchatka Peninsula, so this is closest to where the earthquake would have struck, and obviously there has been significant damage locally there. But from what we can see, and certainly we're inferring now this is a very sparsely populated area. It's also a long way from any large cities and communications. I've actually visited Sakhalin, where this footage was shot, and a lot of areas aren't even accessible by road. So there could have been impacts we're yet to learn of. But these images are telling in a way, because you can see they're filmed from high ground. And something that we know had happened, there's been a cluster of earthquakes in recent weeks in this area, including a very large one on the 20th of July, so not much more than a week ago. And we know there were tsunami alerts issued locally then. I'm speculating here, but I'm wondering if, given the size of this earthquake, people would have felt it, those tsunami warnings would have been issued. And because there'd been foreshocks precipitating this, people might have heeded those warnings, got to higher ground, and that's why we're seeing this. And thankfully, and you heard Ivor there from Moscow, as far as we know, no sort of mass casualties being reported as a result, which is obviously a fantastic thing to hear. But interestingly, just going back to the sort of geology of this earthquake, on that list that you read out, nearly all of those earthquakes, apart from the largest one recorded in Chile a long time ago, are linked to this Pacific Eurasian plate subduction zone, this area around Japan stretching up into the far east of Russia there, where the Pacific plate is disappearing below the Eurasian plate at such speed, I mean, speed in geological terms, about nearly a centimetre a year it's moving. And they think since 1952, when that very large magnitude 9 earthquake struck Kamchatka, about 6 metres worth of stress, of movement on that fault has been building up. And what we might be seeing today is a big release of that pressure. There were some foreshocks that focused it, and now a big shift, so we don't know. Live pictures from Japan here, I think. They've been on high alert for a wave as well. When we were hearing there from Japan, so far only, 3 foot, 1 metre wave, it doesn't sound like much. We've all seen waves bigger on the beach, but we have to remember in a tsunami, just going back to that geological fault, we've got hundreds of kilometres square of seafloor being suddenly jumping upwards. It sends a long wave across the Pacific. So that 1 metre doesn't just bump up onto the shore, it's a surge of water that will continue for as long as that sort of displacement of land happened out at sea. And it's that sort of sustained process of water coming inland that can cause destruction. But it appears, certainly from some of the footage we've seen, coastal defence and things like that seem to be dealing with most of that wave. What we don't yet know in those remoter parts around Kamchatka, the Kuril Islands, Sakhalin. These are very inaccessible, remote parts of Russia, what the impacts might have been.
And what are some of the contributing factors? Obviously, the magnitude of the quake itself. We're seeing that these tsunamis generally associated with big magnitude, 7+. What about things like the depth of the quake that it occurs? What about the depth of the water above that bedrock?
And you're beginning to list some of the factors that contribute to a big tsunami, but also, because there has to be a certain number of combination of factors, why you might have a very big quake like this and not perhaps as devastating a tsunami as we saw, for example, on Boxing Day in Indonesia, where we had the movement of the seafloor. Estimates vary, but it could have been between 10 and 15 metres suddenly shifting upwards in the fraction of a second along a very long strip of coast. But yes, shallow earthquake means more energy gets to the surface of the Earth. This was about 20 kilometres deep. Sounds like a lot, but in geological terms, that's pretty shallow. So a lot of that energy would have gone up to the Earth, to the land that we live on. Under the ocean, depending on how that thrusting happened, and these subduction zone faults are notorious for causing what's called megathrust earthquakes, the ones that push upwards. Depending on the physics, the dynamics, the timing of all that, and yes, the amount of ocean above it, that will dictate the wave. But in terms of how that wave propagates and what destruction it causes, that has a lot to do with what's happening in the ocean as well. This happened on a chain of islands, well, off the Kamchatka Peninsula, but below them is a chain of islands, the Kuril Islands. Could they have helped deflect, baffle, reduce the impact of the wave travelling west? And obviously across the vast reach of the Pacific, thousands and thousands of miles, some of that energy dissipates from the wave, which is why it would be understandable that when it reached Hawaii, it wasn't certainly as large, as much closer to source there. But the kind of all of those factors are almost impossible to model. Scientists can only really learn from them after the fact.
And just the difference between tidal wave and tsunami. Tidal wave kind of lunar influences.
Exactly.
And then tsunami geographical ones.
Exactly. So tidal wave, it's a kind of, yes, in sort of vernacular, it's sort of a big wave, but a tidal wave is caused by tidal forces building up. A tsunami is obviously linked directly to tectonic movement, the thrusts of plates.
Volcanoes?
Well, volcanoes can cause tsunamis if the times they tend to occur is when there's a big collapse. Right. The side of a volcanic island or something like that can cause tsunamis, and that's happened before. But I think just one other interesting thing to note about this, since the Japan earthquake, since the Boxing Day tsunami, alert systems have got better. We're looking at tsunamis in a digital age, if you will. People have mobile phones, alert systems, news travels faster, forecasting is a lot better, and warning systems are a lot better, so people can get alerts to this. And it looks, certainly from some of the evidence we've got coming in from the affected area, those warnings got to people and they were heeded.